Okay, on this video I just want to give you the calculator steps in a problem with ANOVA. And there's a problem here, and you can see that it has 3 columns of numbers, and basically looking at, is there a difference between the three? Are there any differences between population means? Or is at least one of the following true? You remember all that, hopefully. But I just want to show you how to do this on a calculator. So I'm going to hit Stat, Edit, and I'm just going to enter the numbers that are in the ANOVA problem. Into lists 1, 2, and 3 on my calculator. Okay, then to run the ANOVA, you just hit Stat again, and you arrow over to Tests. You can arrow down or up. I'm going to arrow up because it just takes me to the bottom of the list, and the last item on the list is ANOVA, so I'm there a little faster. Then hit Enter. That's going to give you a line that just says ANOVA, open parenthesis. And then, remember our day, we're in lists 1, 2, and 3. If you hit second and then the number 1, you will get L1. If you look on your calculator right up to the upper left-hand corner of the 1, you'll see L1. Then comma. My list 2 also had some data in it, comma. Second, list 3, close parenthesis. And there you have it. There is the F-test value, 4.56, and a p-value, 0.028, so we would reject at the 0.05 level. And then the TI calculator calls this factor. That's the same as treatment. Some will call it group, between groups, treatment or factor all come down to the same thing. There's the degrees of freedom. Remember, treatment or factor is in the numerator, so the degrees of freedom for the numerator is k minus 1, where k is the number of groups. So we've got 2 there. And then MS is the mean square treatment. And then the sum of squares is just the product of the degrees of freedom and the mean squares. There's another way to calculate this stuff. In fact, I have it in the chapter of my text if you want to read and get a little bit clearer idea of what sum of squares means in each one of these. If you see the arrow over here on the left-hand side, that means I can just arrow down, and then you see the mean square error of 3.06, the degrees of freedom of 15. That's just total sample size minus k, and so there are 18 numbers there, minus 3 is 15, and sum of squares. And so if you took the 3.06 times 15, you would get the 46, the sum of squares. In both cases, the sum of squares are similar to, and actually a decomposition of, what we've had in the numerator for our problems where we've computed either variance or standard deviation, that is, the sum of the squared deviations. But anyway, just wanted to show you how to do ANOVA on the calculator. So just briefly review, Stat, Edit, put numbers into lists 1, 2, and 3. Stat, Tests, ANOVA, tell it where the data are at. You have 6 default lists in there. You can put more in there. Or I'll just say it's possible to put more in there. Okay. Hit something wrong there. Well, I've got it back anyway. There you go. And just a review of that.